Section 9.2 we'll cover in one video. I'll show you how to graph rational functions with a calculator at the end, but we're going to start with identifying vertical and horizontal asymptotes and stating the domain and ranges of these graphs. Now, what these graphs are, they're graphs that are y equals and it's a fraction. And the values on the top and the bottom are both polynomial functions. So we have either constant polynomials or maybe linear polynomials or quadratics, but they make a fraction looking type of equation. When you do that, you kind of get these clever shapes. What we're going to see is that they're going to have these things called asymptotes. They're imaginary horizontal or vertical lines. So this blue graph right here at the left is y equals 1 over x. And you can hopefully see there's this horizontal line the graph gets really close to but doesn't cross. That's called a horizontal asymptote. There's also a vertical asymptote. It's a line that's vertical that the graph gets really close to but never crosses. And that's right here. That's the vertical asymptote. So we'll work on defining those as equations. Let's start specifically with this graph here. Y equals negative 4 over x. Looks like this on the right. Now, let's see if you can identify the imaginary horizontal line the graph gets close to but doesn't cross. Hopefully, again, you can see that it's right here. Now, remember the equation of the horizontal line is either x equals or y equals. Well, if you look at it, this line is actually intersecting the y-axis. And it intersects the y-axis at 0. So this horizontal asymptote is y equals 0. Now, let's try to find the vertical asymptote. There's this vertical line the graph gets really close to but doesn't cross. Again, notice this vertical line crosses at the x-axis and it crosses at the number 0. So the equation is simple. It's x equals 0. So I'll write that vertical asymptote is x equals 0. The horizontal was y equals 0. Now the domain and the range. The domain, remember, goes with the x's. The range is with the y. So we're going to actually see that this graph has activity from over here to over here. So as I travel along the x-axis, which is right here, as I'm traveling this direction, I'm going to notice when x is negative 5, negative 4, negative 3, negative 2, negative 1, we actually see points are hitting the graph. So for example, at negative 5, there's graph. At negative 4, there's graph. At negative 3, there's graph activity. But as they're traveling again on this x-axis, there's a certain number that they hit on an x that they tried to graph and they couldn't. What happens is they're graphing this, and when they get the x of 0, which is right here, they couldn't plot a point, so they had to lift up their pencil and continue to draw down here. So there's a break in this graph. Typically, the domain for a function is all real numbers. Normally, any number works for x. But if you think about the mathematics, this value up here, negative 4 over x, there is one number the calculator is not going to let this bottom number be. It'll error out if x is equal to 0 because you cannot do negative 4 divided by 0 in your calculator. You can never divide by 0. So the domain for this function is all real numbers except 0. It's what x cannot be. Now for the y's, the range is the y's. So the y-axis goes up and down. So as you travel along the y-axis, as I'm going this way, I see that there's graph activity over here to the right. And there's all this graph activity. So the graph is drawn going upward, except as they're traveling up, when they hit the y at 0 right here, you're going to notice there's no black graph drawn over here. They couldn't sketch any graph. What they had to do at this point here is lift up their pencil and start redrawing it. So the y activity is the same thing. The range for this is all real numbers, again, except the number 0. That is, y can never equal 0 for an answer on this graph. So on this one here, they've graphed y equals 10 divided by x plus 3, and this is the picture right here. Now be careful on this graph paper, they are counting by twos, so this is 2, 4, 6. That means this is -2, -4, -6. Clearly, you can see that they have the vertical asymptote drawn in there, this red line right here. And if you read it carefully, it looks like x is at the number through -3. So this vertical asymptote is x equals -3. The horizontal asymptote is right here, and it goes right through the origin. So this is crossing the y-axis at y equals 0. So we can fill in that the horizontal asymptote is y equals 0. The vertical asymptote is x equals -3. Again, the domain has everything to do with the x's, and the range has everything to do with the y's. Make this connection here. As they are trying to sketch this graph, they have activity over here in these negative x values. But once they hit this red line or the asymptote, which is the number -3, they couldn't plot a point. They had to lift up their pencil and start over here. So they had to jump at -3. They had to jump at the asymptote. So since the domain is related to the x's and the vertical asymptote is an x1, this actually tells me exactly where the domain has an issue. So the domain again is going to be all real numbers, except what number is not going to work? Well, there's an asymptote, which means it's an issue. It doesn't work at x equals -3 because an asymptote was drawn because they had to lift up their pencil and skip over it to continue to draw. The horizontal asymptote works the same way. If you look at the y activity on the graph paper, here's the y-axis here. You know, as they're traveling on the y-axis, again, we travel upward, we're going to see that there's graph activity over here to the left. But as you get closer to this green line, moving up and down, which is how the y values or the range goes, when we hit the number 0, we have an issue. They have to lift up their pencil to continue to draw. So the y's break and have an issue just where that asymptote happens. Again, the range deals with the y's, which deals with the y asymptote. So on here, the range is all reals, or all real numbers, I'll say, except 0. Now this one here, let me give you a quick sketch of what it looks like. These are our tick marks. I'm actually sketching these asymptotes. What you see sketched in the green is what the graph looks like. The red lines are the actual asymptotes. So be cautious on this. Again, the vertical asymptote is right there, and it's crossing at the x-axis. So the vertical is at x equals -1. The horizontal asymptote is this line right here. And you can see that this graph is approaching the horizontal asymptote, which crosses the y-axis at -1. Keeping in mind the domain and range. The domain is travel on the x-axis here. As we travel on this x-axis this way, we're going to notice there's graph activity, except when we hit the point -1, they lift up their pencil to continue to draw. So the domain, again, is, I'm going to say this, all real numbers except -1, which again, the domain is with the x's, therefore the vertical asymptote, which is stated as an x, will tell me the issue. The range for this one, again, range deals with the y's. So as I travel up this y-axis here, if I travel upward, I see to my left that there's graph activity here. I start to have graph issues where I have to lift up my pencil right here at -1, where that horizontal asymptote is. So the range here, again, is all real numbers except the number -1. Now I just want to show you, if you go to your graphing calculator, what you're going to do is go to your y equals button on graphing calculator, and here's what you have to type for this particular function. Be careful. y equals, I'm going to put the top in parentheses. So it's going to be in parentheses x caret 2, close it out. This division bar here on the fraction is just the division bar. So type that. Then in parentheses, I'm going to do x caret 2 minus 1 and close it out. I always recommend when you type it into the graphing calculator to put the number or the value up here in parentheses and this one in the parentheses so you don't make a mistake. After you're done with that, hit the graph button and you should get the following graph. Here's what the graph's going to look like. Now I will tell you this one has 2 vertical asymptotes and 1 horizontal. One of the vertical asymptotes is right here and the other is right here. They're going to happen when x is equal to -1 and when x is equal to 1. So I'll write those down over here for my answers. Now the horizontal asymptote, you have to be careful, is a little bit higher. It's where these 2 curves at the top get close. It's going to be right here. And if you look at that, you can see it's going to be crossing the y-axis at 1. So the horizontal asymptote is y equals 1. Now this graph also happens to have an x-intercept. Where does it cross the x-axis is going to be right here. Remember, you could use your features of finding the zeros of the function, or you can identify it. The x-intercept happens at the ordered pair 0, 0. Now let's have you type this one in the calculator. Be careful. You're going to type y equals as your format, but in parentheses 4x, then your division sign, in parentheses 2x plus 1. When you do that, you're going to end up getting this graph. It'll look something like this. Now this does have a horizontal and vertical asymptote. The horizontal one is going to be right here, and it crosses at y equals 2. The vertical is about right here, and it's a nice fraction, I will tell you that. It happens at x equals -1/2. This thing does have an x-intercept where it crosses the x-axis, actually happens to be right here, and it ends up being the ordered pair 0, 0.